Imagine trying to train an AI to read brainwaves, but the standard training method randomly crushes or distorts the very signals you are trying to analyze. This scenario highlights the core flaw of using random data augmentation on biological signals. This paper introduces RL-BioAug, a solution that puts a reinforcement learning agent in charge of protecting data integrity. To understand why this matters, we first need to look at how contrastive learning usually works. Traditional methods apply one-size-fits-all noise to data, which can be disastrous for EEG signals that change drastically across sleep stages or seizures. The researchers propose replacing this random guessing game with an adaptive agent that learns exactly which modification fits the current brain state. This diagram illustrates the cooperative loop that drives the system. First, the agent observes the current brain state through a frozen encoder and selects a strong augmentation, like time masking or cropping. The system then updates the encoder using this intelligent view, and finally, the agent receives a reward based on whether the class identity was preserved. What makes this approach particularly clever is how it handles data labeling. The reinforcement learning policy is trained on just 10% of the labeled data to learn what good looks like, using a soft KNN reward signal. Once the agent knows the rules, it guides the massive self-supervised encoder training process on the remaining unlabeled data. The results show that this adaptive strategy pays off significantly, beating random baselines by nearly 10% on sleep classification tasks. Even more fascinating is that the agent autonomously discovered domain knowledge. It learned that masking time segments helps analyze sleep stages, while resizing crops is better for detecting seizures. This paper demonstrates that for complex biological data, we should stop guessing at data augmentations and start learning them. For more deep dives into AI research, visit emergentmind.com.